the output that we expected. So I'm going to shift now to an actual editor. For editing all my files, I use right now for Ruby at least. I've used many different IDEs and other tools, but for the purpose of this class, I'll be using what's called Atom. Atom is a editor made by GitHub. In my opinion, it's probably one of the better ones. You can also use Sublime Text. It's very good. I've used a whole bunch of different ones. For the stuff that we're doing, I would refrain from using any one IDE. I do know that Atom provides plugins for all the languages that we're working with, so that there's syntax highlighting for all of them. I'm pretty sure Sublime Text does as well. You'd be hard-pressed to find editors IDEs that easily do all this, although for Ruby and Java, I do know that the JetBrains company makes pretty good editors for both of those languages. So, shifting away to this, we now see that this was the example we were just editing. The reason I like Atom is because I also have the ability to have a terminal in there. Not that you can't have that in other languages, just happens to be that I like it to have it in this one. We will be running a few different things. The next thing we're going to look at is, what is the value of truth? What makes things true in Ruby? And so we'll create a new file really quick. We'll call it ex2rb. And so let's think about this, right? So let's go back to our this appears to be true stuff. Right, so if I say this appears to be true, and then now if I want conditional, if I say if 1, we would expect that if we were thinking like in C, but not in Java, that in C, if I did a conditional expression just evaluating 1, that evaluates to be true. And so if I say Ruby ex2.rb, we see that that is also true here, right? 1 appears to be a truth value. If I do the same thing, but instead this time I just choose random string, well, we might think, well, that might not work out quite as well, but in fact it does, right? It gives us a warning that we use a string literal in a condition, but the interesting thing here is that we will find that pretty much anything that's an actual valid object turns out to be true. And that means that if I put in if 0, which if we were recall from when we program in C, if we do a conditional expression with 0, that will evaluate to be false. But in Ruby, that is not the case. The only thing that evaluates to false, right, and then of course true also evaluates to true, but the only things that we'll find that evaluate to false are themselves false and the value nil. Which would correspond to null in Java. So, this is just something to be aware of inside of Ruby. Now, if we go and execute this one more time, we can see, just be sure that the first 4 items do evaluate to be true, right? Actually, and then the last 2, they don't print anything out, right? Because they evaluated false. So, we want to verify that that was in fact correct. Now, I will run the IRB here in Atom just because there's a few things I wanted to show when we were talking about Boolean logic. So IRB, let's say we have, let's see if I can bring this up a little bit so it's a little easier to see, and we say Control L. Alright, so we're in here, right? Now, if we use the AND operator, which is just like the double ampersand, if we say true and false, right, we expect this to come out to be false. If we say true and then or, true or false, we expect that to be true. If we say false, double ampersand false, we expect that to be false. If we say true, double ampersand, this will cause an error. This will cause an error is some unknown variable. We expect that to throw an exception because, well, it doesn't know what that is. So, but if we were to execute false and this will cause an error, we see, oh, hello, not false E. If we run that, we see just false, right? Because it uses short circuit logic. It will handle it as soon as it sees a false. in an AND condition, it automatically evaluates to false. If it sees a true in an OR condition, it automatically evaluates to true. And we can see that again. If we try true or that thing, we get true, right? Same if we use the double bar. Now, in Ruby, you can also use a single bar. Now, what this does is this says we're not going to use short circuit logic, mainly because we might have some function call or something that has to be evaluated as a part of this condition, so a side effect. And so we want the whole thing to be evaluated. Well, when we do that, we get the error again. And we can also do the same thing if we did false and a single ampersand. It will cause the error as well. So, just to be aware of all this. Now, if we go back to writing code in the editor, I'll clear this out, and so we can actually see what's going on. We can start moving on to a little bit more information about strings. So as we already talked about, strings can be identified using single or double quotes, and we can also do string interpolation with the hash and the curly braces around a statement inside Ruby. So as I said before, let's say we say PA equals, and then the hash, and then we put an A, right? We'd expect to see the value 17 printed out. So we run this as Ruby ex3 to RB, and we see that happens. Okay, everything looks great, except for if we do P single quote A, and then the hash mark A. If we do that, as I said before, it will not evaluate it. It will show us literally what we typed in. And so that's why we have to use double quotes. Now, sometimes, if we're extremely verbose people, and I know I am, we can use a extra long string, or a multi-line string, by using a triple quote. So this is a longer string, perhaps some instructions or agreement. I can't spell agreement. Goes here. By the way, A equals A, right? And so we can still do interpolation, and that's because we used a double quote, right? So if we go ahead and print B, we will see all this worked out. Actually, we'll put puts because it makes it a little more pretty to look at. We'll run it again, and lo and behold, actually, puts did not give me the prettiest view of that. But anyway, so we see that it converted to the string, and A equals 17 as expected. If we did the same thing with a single line, it would kind of, a single quote for triple quotes, it would give us a completely different thing. Now, there are a couple other ways to do that. I'm not going to dwell on it too much. I'm not too concerned about that. There are some other things that we can do with strings. For example, if we say S equals, hi there, how are you? And then we want to print that, right? So we say, let's say puts s.length. So if we want to find the length of the string, we just call the length method on it. And then we can also print s, right? So let's go ahead and do that, see what happens. And we see it's 22. That's the length of the string, hi there, how are you? We can do some other things, like if we need to access an individual item inside the string, we can say puts, and then if we just want, actually we'll do print. If we want the the character at the fourth index of string s, we can say 4 in brackets as if we were accessing an array, /n. We want to, and we look at that, and we see it's h, right? The fourth index, which is the h in there. Alright, similarly, we can use printf to do the same thing, and we say %c/n, we say s4, and lo and behold, we get the same thing. Now, we can also substring, and so we substring items by, in the brackets, we put some n, some l, where n is the start position, so the start index, and L is the length of the substring, right? So if we do that, we can say puts s, and let's say 4 by 4. Maybe we want to make this a, let's interpolate this. And we'll put square brackets around all of it. Sure, that sounds good. And then, furthermore, we can also use a range, right? So range, which is some n to some m, which is inclusive, right? So that extracts characters starting extracts a string starting at index n up to index m inclusive. If you did a range n triple dot m, it's the same thing. Extracts a string starting at index n up to but not including m. So for example, if we want to do this we'll do 3 of these, right? And we say this would be s, and we'll say, I don't know, let's try 6 through 15, and we'll do the same thing again, except for it'll be triple dot. This would be s 6 15, just to validate, and we end that string. Hello. Okay, very good. Let me run that, and as we see, we have oh, my bad. But anyway, so it says the first 4 characters, the 4 characters starting at index 4 was here, and then starting from index 6, which is it gives us up through 15, which would be this, and then of course up into but not including 15 would be 1 less than the previous one. So it looks good. All right. We can also we can also manipulate strings by saying, for example, if we want to, let's say we have the string wow, and we want to wow with a space. We want to maybe, I don't know, print that same thing out 3 different times. We can just call multiply it by 3, and we can see what that does. And it says wow, 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 and then it's good to go, right? So we can do all these different things. We can also access, or we can find out what is the index of. So we can say print s.index there, actually there with lowercase. We can also plus the space. We can index s. This is why you should always use interpolation. S.index, right? And that looks for the what is the index of the first occurrence of the string that is in parentheses there. We can say s.index of how, and I'll put that in string interpolation. See if I can do that. Okay. And we say string interpolation s.index of bogus, right? Which doesn't exist, and so it would return nil instead of a -1 or something like that from like Java. So if we did this, it goes ahead and it prints 3, 10, and nothing, right? So when nil is converted to a string, it converts to the empty string. So we just need to be aware of that. Finally, we can also reverse a string. We can just call the reverse method, and lo and behold, it reverses the string as we expect. Okay, so that's pretty much the basic concepts. Well, I think we got... Oh, there's a few other things that we can do with strings. Just so we can do this, it'll look hopefully interesting. There's a few other things you can do. You can, for example, and I'm not going to go too deep into this, but you can chomp a string. Chomp removes white space from the end of a string, the last character specifically. So let's say we print and we say, please enter a past tense. Let's just enter a noun. I don't want to get too deep into this. And then we say noun equals gets. Gets just like puts things to the standard out. Gets takes in input from standard in. So then we say gets.chomp. So gets returns a string, right? So get string, just like puts is put string. So we say chomp. Chomp removes the last item from that incoming string. So in this case, it will be the /n that we're trying to get rid of. And so then if we print it, right, we say put noun, and we do that, run this, and now it's waiting for me to type something in. So I can say Isaac, that's my name, and then it prints that out. All right.